what it really comes down to for this factor, folks, is you need to know how to do this. You need to know how to factor. And, you know, I'm happy about this 1, 2, 3, 4, 5, 6, 7 people in here that actually did the homework. This is not the kind of thing that we just go through quickly and write down the answers to. That's not going to work. You're going to have to actually work at this stuff. You have to set it up. You have to solve it out. You're not going to solve these by just looking at the equations. Most of them. I mean, if you do it, number 7, 7b squared minus 25b minus 50. You make it 7. Okay, and we want to factor that polynomial. The method that we're using for this, and by the way, if you didn't do all your homework, you should probably have your worksheet out right now. Yeah. Once you do some homework, then you can get a drink. Other than that, sit down. Sit and be quiet. Okay. You want privileges, do some of the work. All right. So yeah, if you don't have your worksheet out, if you didn't do it, get it out. Everyone. If you don't have your worksheet with you, get out a piece of paper. Because one of the problems people are having is they've been coming in for questions on this stuff, and they say, well, where are the notes you took on factoring? Well, I didn't take any notes. I just watched you do it. Useless, pretty much. I mean, there are 2 or 3 people that might be able to learn that way, but for the most part, no. Okay, get something out. Everybody. Everybody get out a piece of paper. Because I want you to take some notes on this process. If you don't know how to do it, you're going to need that. If you're really good at it and you did all your homework, at least have your worksheet in front of you that you did it on so you can follow through to see if you did it correctly. Okay? I do. It's where?
It's on your right side. On the right. See it? There you go.
Oh, it's off my pair.
Oh, you had a pair?
Yes. It was, actually, quite. Thank you. Okay. So, again, the process we need here is what we called, and we did this on Friday very clearly, the AC method. So, I look at this and this. I multiply those two numbers together. 7 times negative 50 is negative 350. That's the product we're looking for. The sum we're looking for comes still from the middle term, negative 25. So I need 2 numbers multiplied to give me negative 350 and add to give me negative 25. Now, that may or may not be obvious to you what those numbers are. That may or may not be. And if it's not, which it isn't for about 90% of the people, we just get systematic about it. And we start thinking, okay, well, that's negative 350 times 1. That's going to be negative 349 if I add them. Okay? This is a sum of whatever these numbers are. That's not going to work. If I take 350 divided 2, that's negative 175 times 2. That'd be negative 173. That's not negative 25. We just get systematic about it and start checking. It does take a little time sometimes. So 353 doesn't go in. Does 4? Nope. 350 divided by 5, well, 350 divided by 5, that's 70. Negative 65. I don't believe 6 goes into 350. 7 does not. 8, I don't believe so. No. 9, no. 10. Negative 35 times 10. There's my magic number combination. So it takes a little guess and check to find that magic number combination. But once we found it, the hardest part is done. Once we found that magic number combination, this part is done. You should, by the way, jotting this down. not just sitting there. Okay? I'm glad some of you got a piece of paper in front of you. If you're just sitting there with a piece of paper in front of you doing nothing, you're not doing anything yet. Get a pencil out. Start actually taking notes on it. And not drawing pictures with it or cutting things out of it, Jake. What? Yeah, 7 does. Well, we found a combination anyway. I wasn't sure. Oh, you're right, it does. Okay. Nonetheless, we continue. Now that I've got this, I rewrite this polynomial, splitting the middle term into negative 35x plus 10x. The 7x squared stays the same. The minus 50 stays the same. But we split that up, and the reason why is because now it'll factor for us. Now it factors just fine. We group the first two. And we group the second two. If this sign was a minus sign, we'd have to change the sign inside here. But it's a plus sign, so we're good. Take the greatest common factor from the first two, which would be what? 7x, leaving me minus 5 plus 10, leaving me an x minus 5. And then the common factor is the x minus 5. From this row, the common factor is the x minus 5, leaving me a 7x plus 10. Now, the only difference on the back side was that we added equals 0. Nothing changes the entire process of the equals 0 thing until the very end. We still have to factor. Then we just say, okay, if that equals 0, that means that either this equals 0, either one of the factors equals 0. What value of x would make this factor into a 0? A 5. This is a little trickier, but it's not bad. Again, it's always the opposite of this over the coefficient, 7ths. So x equals 5 or negative 10/7. All right? Now, really, this is all you had to do for that particular problem right here in the homework. But you should have that done. Now, let's check to see who actually took notes on that. If you had your homework done, then you had it done. If you didn't, I'd want to actually see the whole process written out. Okay. 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 You actually did it? You wrote it all out. Nothing, huh? Okay. There we go. Do it, okay. That's what you need to do. That's how you're going to learn it. Do it? Okay. All right. Well, let's do one more. Give you one more chance to take some notes on this stuff. And again, take the notes as we go over it. You didn't do it the first time. So let's look at something that has the process here. Let's 22. 7n squared plus 22n minus 24 equals 0. I think that was it. I'm going to make sure I got my signs right. Yes. We need to factor that. We start out by looking at, again, A and C. We multiply those together. 7 times negative 24 which I don't know off the top of my head, but isn't too bad. Negative 168. So negative 168 is my product, and 22 is going to be the sum I'm looking for. Again, probably not obvious, so we start out. Negative 168 and 1 is going to give me negative 160, or positive 168. Try again. They both have to be negative, actually. No. Sorry. I'm thinking of a different problem I did last hour. Product's negative, so one's negative, one positive. The bigger one has to be the positive because that is, so it's 168, and negative 1 will give me 167. That obviously doesn't work. 2 into 168 is what, 82 or 84? So that gives me an 82. Does 3 go into 168? Well, there's one way to find out. 168 divided by 3 is 56. So that's 53. 168 divided by 4, 42. That gives me a 38. 168 divided by 5 does not come out evenly. 168 divided by 6 does. It's 28. There it is. Ding, ding. So, again, we just kind of take it systematically until we find our correct product. Then, once we get that, we substitute those values in. So 28 and negative 6. So it's 7n squared. The 22n is what we split up. It becomes 28n minus 6n. And the minus 24. Still equals 0. Equals 0 is just along for the ride to the very end. We group it. Now this time I did group after a minus sign, so I have to change the sign inside the parentheses to make it work. We talked about that on Friday. It's because this was a negative 6n. When I put the parentheses in, the negative 6 became positive. We actually did change this sign by putting the parentheses there, so I got to change that sign also. It's like factoring out a negative 1. Then I find the greatest common factor. Greatest common factor here is 7n, leaving me n plus 4 minus, because the minus sign is there. Common factor here is leaving me an n plus 4. These two match, they better. So n plus 4 is the common factor, leaving me a 7n minus 6. And again, just as before, it still equals 0. The amount equals 0 belongs to the right. What value of n would make this one 0? Negative 4, and this would be positive 6, opposite of this over that. And we've got our solution for factoring. All right, again, let's check to see. We actually got the notes done on this. This is what it takes sometimes. All right. Nothing still, Jake. Cool, maybe take notes. No, I'm not kidding. Jacob, why don't you just go sit down in the office, okay? Because you're refusing to do anything in here except chat and have conversations and kind of disrupt other people. So if you're not going to do anything, you might as well just leave. Okay? Come back when you're ready to start doing something. I'm done dealing with it. All right, so factoring, again, good way to solve equations. Problem is, not everything is going to solve by factoring. I mean, for the most part, we've just been working with polynomials that do factor, but the fact of the matter is, not everything does. Let's say I have 2x squared plus 4x minus 5 equals 0 is a problem. Now I got to factor that. Well, my product has to be negative 10. My sum has to be 4. So let's see what we come up with. Negative 10. Well, that's going to be negative or positive 10 times negative 1 would give me a 9. Positive 5 times negative 2 is going to give me a 3. And I'm kind of out, aren't I? I only have many choices of 10. So when I look at that, I'm not going to be able to solve that factor. It's not going to factor. When that happens, we still have a way of solving these. And that's the quadratic formula. And that's what we're working with today. The quadratic formula for the equation, when the equation is in the form, standard form, ax squared plus bx plus c equals 0. The solutions are at x equals negative b plus or minus the square root of b squared minus 4ac over 2a. That's a formula you should have picked up last year. You've seen it before. It is a rather complicated formula, but it's one that's very useful. What it does, it doesn't give me factors, it actually gives me the solutions to the equation. It doesn't give me the factors, it gives me the roots. These are the actual values of x at work. These values of x, when it doesn't factor, are not nice numbers in many cases. But that's okay. We can find them. So again, the a, b, and c come from the equation. So there's a, there's b, there's c. So in this case, a is 2, b is 4, and c is negative 5. So what we do is we just put in the formula and leave it in radical form. So negative b plus or minus the square root of b squared. Here, I'll write it out actually slower. 4, no highlighter, please. Thank you. Minus 4 times a times c over 2 times a. And then we just solve that out. This would be negative 4 plus or minus the square root of 16. This would be 8 times 5 is negative 40, so minus negative 40, which is plus 40, over 4. Negative 4 plus or minus the square root of 56 over 4. Those are the values of x that will make this 0. If x equals negative 4 plus the square root of 56 over 4, if x equals negative 4 minus the square root of 56 over 4. Not nice numbers. But still two solutions, one with a plus, one with a minus. Now, could we simplify that? Yes. I mean, for now, I'd probably be pretty happy with that result. But yes, that does simplify. First off, I can't cancel the 4 with the 4. You can't cancel parts of polynomials. I mean, think about this for a second. If I have 2 plus 3 over 2, can I just cancel these 2's and get that to equal 3? Does that work? Well, no, of course not, because 2 plus 3 over 2 is 5 halves, or 2.5. Right? Not 3. I can't cancel parts of sums and differences, only factors. So I'm not allowed to do, I can leave that up. So I'm not allowed to do that. So I could simplify, though. Root 56 is 4 times 14. So that's 2 root 14. So I could say this is negative 4 plus or minus 2 root 14 over 4. And then if I wanted to, I could actually factor the numerator here, take a 2 out of that, so that's negative, or 2 times negative 2 plus or minus root 14 over 4. And now I could cancel the factors. So that's negative 2 plus or minus root 14 over 2. And that's as far as that one goes. But really for today, I'd just be concerned getting here. Concerned about getting there using the formula. If you can simplify it, great. But that's not the battle I'm fighting right now. And quadratic formula gives us the solution for any quadratic equation. Let's go back to the one we just did. Let's go back to 7x squared plus 24x minus 22 equals 0. We just factored that, so we know it has solutions. And if I put it in the quadratic formula, we get negative b plus or minus the square root of b squared. I copied that down wrong, I think. This is plus 22 and 24, right? Sorry. There we go. So negative 22. So 22 squared minus 4 times 7 times negative 24 all over 2 times 7. So that's negative 22 plus or minus the square root of 484 minus minus is going to give you a plus. And then 28 times 24, there it is. 672 over 14. Square root of 44 plus 672 is 34. It was a perfect square. If you're using a quadratic formula and you get a perfect square, it means you could have factored it. So negative 22 plus 34 over 14 and negative 22 minus 34 over 14. This is 12 over 14, which is 6/7. This is negative 56 over 14, which is negative 4. What were the solutions I came up for when I factored it? Negative 4 and 6/7. Okay? Factoring it is actually less work. But we can use quadratic formula to solve things. However, just realize on the quiz on Wednesday, you will be asked to use both methods. You'll be asked specifically, yes. Yes, you should. Oh, it's not that bad. You should have the quadratic formula memorized already. That's really a critical formula. What's algebra 1? This is geometry. We memorized some basic formulas here. I don't have the quadratic formula song. What time is this out? Oh, we got, there's no need to pack up. We need to pack up. We aren't done yet. I want to do another one. One more. 3x squared minus 5x plus 7. Okay? Let's take a look. Negative b, which would be positive 5, plus or minus the square root of 5 squared minus 4 times 3 times 7 over 2 times 3. That's 5 plus or minus the square root of 25 minus 84 over 6. That's 5 plus or minus the square root of negative 59 over 6. What's wrong? Square root of negative 59 is undefined, isn't it, in the real numbers that we're working in? Now, I've said this before. There actually is something we can do with square root of negative 59. It's in something, but it's in the complex numbers. And we aren't going to worry about that. For now, we would say there are no real roots. Okay, this does not solve. There are roots there, just not real or complex. So it's possible as you put a quadratic in, not every quadratic is even going to have a solution in the real numbers. Sometimes you have to use a bigger number system called the complex numbers to get to our solution. All right, got another worksheet for you for this. Tomorrow's a review. Quizzes on Wednesday, all on factoring and this sort of thing. So.
I don't know why. I think I just like to the paper. I don't have to read what's your marker. Yeah.